everyone, welcome back to the Hey King channel. Just want to let you know there's just perhaps maybe going to be a bit more background noises just because of where I'm filming at the moment. So today we are learning about how to prove and apply similar triangles. It is a difficult concept, so by all means you can pause at any time of the video just to go back and play what you are being taught today. So today's learning intention is to understand how to identify and prove similar triangles exist. And to do that, we need to be able to identify the sides and the angles and pretty much show what the triangles have that are common to say that they are similar or congruent. So today's success criteria is that you can identify similar triangles, you can prove that similar triangles exist, and that you can use the similarity of triangles to solve a problem, including worded problems. So let's get right into it. So the first example we're going to look at is up the top here, in the top right. So we can see the letters, A, B, C, D, and E. So I can already tell that there's two triangles. This is the first one, and this is the second one. All right, and they are different sizes. Okay. So how do we prove that they're similar? So what we need to look at is, first we can look at angle BAC. What does angle BAC look like? So we know that the middle letter that we list is always the angle we're looking at. So BAC, we're looking at this angle here because A is the angle we're looking at, and equals angle, this means angle, okay, equals angle DEC, so DEC. All right, and that's because they're alternate angles. And we can tell that DE is parallel to AB, okay? So two lines like that means parallel. Don't get confused with three lines because three lines is congruent, all right? So DE is parallel to AB, and we can tell that by these little arrows here that show that, if we were to get a ruler and continue to draw the line, they would essentially never touch. And that's what is a characteristic of a parallel line. So if we look at the next proving statement, we can see that angle ABC, so we're looking at B, and angle EDC, okay, are equal to each other. So I'm just going to erase that so we don't get confused. So angle ABC, which is over here, all right, ABC, and angle EDC, over here, okay? And these two are alternate angles as well, and like as written, DE is parallel to AB, all right? Not equal, it's parallel. So the last thing that we need to prove, okay, for these two triangles to exist is that angle ACB, so AC, this one's C here, B, is equal to ECD, and that's because they're vertically opposite angles, all right? Because if I was to draw a circle around that whole little cross point there, this one here and this one here would equal the same, and this one and that one there would equal the same, and the whole circle would equal 360 degrees, all right? Now, before you determine what steps you're, going to list and show whether the triangles are congruent or not, you need to determine whether the triangle is, angle, 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 side, 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 or right-hand side, all right? So that would have been covered in the earlier exercises, and if you have any questions, feel free to ask your teacher. So just down here, it just shows you, that, this angle here with the little square and this one here, they're alternate. And this black dot here, B, and this black dot here, D, is also alternate. So alternate angles are the same, and that's how we can tell they're similar because they essentially have the same angles within them. Okay, so this big triangle here, the square, the dot, and the vertically opposite angle, all right, would equal the same as the square, the dot, and the vertically opposite angle. And that's how we can prove that they are similar. So now we're going to try a different one. So here you got to prove that this triangle here is similar, but you can see that the triangle is like within the triangle, not really part of it. So the first thing you can do is you can have a look and see that angle ACE, so C and A, is equal to angle DCB. So let's find that. ACB, so we're looking at angle C. And DCB, we're still looking at C. Okay, they're common, meaning they're the same. They're equal. Do we see that? So now, what we can see is that they've given us these little random sides over here. What do we do about that? So in order to find that if these two triangles, this one here and this one here, okay, I'm saying the big triangle, are similar, is that we need to find the scale factor, all right, for both pairs, all right, to see if they equal the same. And to do that, okay, we could say, I usually get the largest number, so AC. So if we look at AC, this line here, which one is that? Is that 4 or is that 18? And we can see AC is 18, so we will put 18 on top. DC, which one is DC? DC, okay? DC, which is 6, all right? So you put 6 there. And this is the same as saying 18 divided by 6, and that would equal 3, all right? Remember, the vinculum can also be assumed as a division sign. So if we look at this one over here, you can see that EC, which is the big 12 over here, all right, over BC, okay, which is over here, which is 4. So 12 over 4, which is 3. And we can see that the scale factor both equals the same, 3. And that's how we can say that these sides, all right, that's a side, and this one's an angle, okay, and we could say, therefore, triangle ACE is congruent or similar to triangle DCB, and that was through side angle side. So we're going to try another one, all right? So this one here is another one where the triangle is within the triangle again. So the first thing we could do is, I can see that these two are parallel, so that's a good start, we're given some clues. So you need to think about, well, what angles could be the same? So for starters, we can see that C, ACE, and BCD would be the same. It's common, okay? They both have it. They both have angle C, okay? Do we see that? So now that we know that this one here is an angle, and that's okay, we know that we're dealing with one of the choices that have an A in it. There's side, angle, side, etc. So we're not dealing with side, angle, side. We're not dealing with right-hand side. Okay, we're either dealing with this one or this one. Okay, so angle CAE, so CAE is CAE, that's this one here, is equal to angle CBD. And I can tell that's a right angle, okay, because generally speaking, a right angle is when two lines are perpendicular to each other. So just a recap, perpendicular looks like that. It's where it's like a T intersection, sort of. Yeah. So, and that one there would be an angle again. So that's your little right angle. All right. Now you've got angle ACE. So let's find AEC. So that's this one here, is equal to angle BDC, and that's because these two are parallel, okay? So because they're parallel, they're actually corresponding. They're corresponding angles. And so that's how we know they're equal. So yes, you do need to think about your previous knowledge on angles and apply that to being able to identify the similarity of triangles. So you must always remember to do a final statement in your working out. That is why right here it was a bit difficult for me to find this symbol, so I've actually just snipped it out. It's therefore triangle ACE is congruent to triangle BCD. And that's through angle, 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 okay? Now, you might be wondering, does it matter about this order? Yes and no. So yes, it matters because if I read the triangle as ACE, so let's just see this one, ACE. So I went from left to the right to up, yep. And then this is BCD, so I went from here to right to up. So you got to be reading the triangle the same way, all right? You could have done, angle CEA if you wanted to. You could start here and go CEA, but that means that you have to say sorry, let me redo that triangle. You have to say triangle CEA is congruent to triangle. So I started from C, so I did CEA, so I'd have to do CDB. So you always need to think about whatever you write first and which way you're labeling, that's the way that the second half of your statement has to be written. You can't just do a random order. Like, oh, I see A and I see E, I'm just going to write whatever order. No. Okay? And it's a good habit to get into. So let's look at the next example here. You need to prove that each of the following triangles are similar. So we can see, you know, they've given us the weird side that we were looking at before. So angle CAD, okay, CAD, all right, so we're looking at this angle here, is equal to EAB, okay? And you're pretty much dealing with angle A. You could have done BAE or EAB, and that would have been the same because the A is still in the middle, all right? And that's angle A, all right? Actually, to be honest, I probably would prefer you to have done BAE for Bay, all right, angle Bay, because that is the way that the first one was written. So CAD and BAE, okay? So do angle BAE. It's just best to get into the rhythm of it. So the next step we have to do after we've identified the angle is we need to think about whether the sides are equal. So to do that, you need to find the scale factor. So to do that, you would do AD, so AD, which is 9, okay, over BA, all right? And that's 3. So you might be wondering, why are we doing it over these two and not these two? It's just, it's because you're not dealing with the one that's near it. You're dealing with the other one. It's just how it is, the opposite one. So, for example, now that I've done 9 and 3, I will now do 7.5 and 2.5 as my next fraction. And then that would give you 3. They both would give you 3. So we know that they're equal. Okay, and that's side. And so therefore, triangle ACD is congruent to ACD is congruent to ABE. Okay? That's what we would say. So for side, angle, side. So you must always state that the triangle is congruent to each other. Don't forget the last line, alright? Okay, let's do the first worded problem. So here we got Chris's shadow is 1.2 meters long when a 1 meter vertical stick has a shadow of 0.8 meters long. So it's really good to just draw a picture. I would highly recommend it, especially when you have a worded problem. So part A says, give a reason why the two triangles are similar. Well, you can see that all angles are the same because they both have an acute angle there, okay? They both would have a right angle there, meaning that this angle here is probably going to be similar, okay? So when we look at that, we can see that they're quite similar. They just have different sizes, correct? Yeah. So now for part B, determine Chris's height. You need to find the scale factor. So you can see that they've done 1.2 over 0.8, which is like the sides of the triangle we were dealing with over here, but now they're next door to each other. So 1.2 over 0.8 is 1.5. So you want to find this length here. That's Chris's height. That's why there's like a man standing there. Okay. And to find that, you need to times the 1 meter to get that. Because these two, okay, to get from 0.8 to 1.2, you got to times by 1.5. Okay. So to get from 1 meter to here, you got to times it by 1.5 as well. And that is how you would get Chris's height, as 1.5 meters. Because 1 times 1.5 is 1.5 meters. So we're going to do another worded problem. Okay. So here we can see we have to give reasons to why these triangles are similar. So we can see they both have a right angle. Okay. They both have vertically opposite angles there. All right. And this angle right here is most likely going to be similar. Okay, and I'm just doing 2 lines so you know that they're different angles to those ones. And you'll see that sometimes. You'll see sometimes that, well, let me just redraw that triangle. You'll see sometimes that that they have these multiple lines on the triangle. It's just showing you that all 3 triangles have, all 3 points and angles in the triangle are different. That's why they use that. So we know that the last angle must be the same since the angle of a triangle is 180 degrees. Okay, so these are the same, meaning that that is most likely going to be the same as that one there, because all triangles equal to 180, and if it was something different, it wouldn't equal to 180. Alright, so now we got to find the distance of the road of DE. So DE is this one here. Okay, so we can see 6 and 3, okay, so they're opposites. So we do DC is 6, CA is 3, so 6 over 3 is 2, okay, and that's the scale factor. So now that we know the scale factor, we just have to multiply BA, which is 4, by the scale factor to give us DE. There's a lot of steps and a lot of looking and identifying, so you need to make sure that you are correctly identifying the right number to multiply by the scale factor. So we know 4 times 2 is 8. Make sure you do your units of measurement because that's quite important to get the mark. So 4 times 2 is 8 meters, okay, it's not 8 apples or 8 bananas, alright, and you can write therefore, I can't even write it because the thing's popping up, but you'd write therefore DE equals 8 meters. Okay, so word problems, you're just going to have to keep practicing. And if you're unsure of the question, feel free to ask your teacher. And with that said, thank you for watching today, and we will see you in class, and stay tuned for the next video. Thanks, bye.